All right. Well, thanks everyone for coming to my talk after that awesome Offspring concert. Appreciate you getting up for this. I'll just go ahead and get started. My name is Francisco Donoso, and I'm currently doing security and DevOps at a startup that just came out of stealth on Thursday. We're building a nation-state caliber attack platform to let organizations test their defenses against a very well-funded and well-instrumented adversary. Prior to that, I worked as a lead architect running a team of architects at a Swiss cybersecurity company, but I've also been a security engineer, done the consultant thing, and probably my best and most fun job of all, I was a security analyst trying to catch other people. Just to give you guys a quick reminder and some context about this talk, about April of last year, of 2017, there was a release by a group known as the Shadow Brokers, where in their Lost in Translation leak, they actually leaked quite a few of the Equations Group's exploit tools, their exploits, as well as their post-exploitation tools. And there were also some operational notes from an operator targeting a Middle Eastern SWIFT organization. And I actually just started digging into this right away. Everybody who I saw online was really focusing on their kick-ass exploits, you know, the Eternal Blue, Eternal Romance, and all that stuff. But those things get patched. Tradecraft and kind of capabilities that they've built over time do not. And I personally really always wanted to know about true like APT capabilities. We normally see it from the other side. We see the artifacts that an APT or some kind of like well-funded adversary has left after an organization goes and does some reverse engineering. This was the first time we could actually use them and see how they worked, so that was pretty cool. I'm also here hoping that I encourage others to reverse engineer and just poke around at these tools. It looks like it took them a good 13, 15 years to build this tool set. So there's a lot of stuff to dig into. I'm not a reverse engineer by trade, but I'm learning my way through it, and I just hope all you look at it as well. And at the time, I wanted a technical side project. I was just a manager telling architects what to do, who told engineers what to do, who then actually did the stuff. Now I'm hands-on, which is cool. So quick overview of what we'll be talking about today. I'm just going to give you a really brief intro into Danderspritz, which is the larger post-exploitation framework that Killsuit is included in, along with a ton of other awesome tools. And if you're interested in how those tools work at a greater level, I actually did a talk last year at DerbyCon titled Danderspritz, where I covered that. So if you're interested, go check that out. Then we'll get to how exactly the Equation Group got to post-exploitation, like how they went from nothing to post-exploitation in a few novel ways, and then talk more about Killsuit and how it actually works and its capabilities. So just a brief overview of Danderspritz, as I mentioned. What is Danderspritz? Well, first of all, Danderspritz is actually really freaking cool. I've never seen a tool set that's as comprehensive or as capable as this one. It's a fully functional post-exploitation framework. So that means you go from living on a machine to data and recon gathering, lateral movement, persisting on a machine, like stealthy exfil, all that stuff is included in the framework. The actual framework is written in Java, but it's extremely modular. And the way they make it extremely modular is by adding a bunch of plugins. And plugins can be written either in a custom scripting language, which were sort of later deprecated, as well as Python scripts, which is awesome. It was easy for me to look at that. It's also designed for stealth. A lot of what the Equation Group did was make sure that they were not caught, that they didn't blow their operation. And they actually did that by building in a lot of safety mechanisms that prevent even dumb operators from making a mistake that's going to get them caught, as well as the platform itself has a lot of tooling to prevent it from doing something automatically that may get it caught by something on the machine or just a good blue team. So I'll just be giving you a brief overview of what it looks like the Equation Group built in terms of tooling and when. It looks like what we see in this leak sort of all started being built around 2001. And the Danderspritz capability as it looks like today, which was from 2013 when it leaked, was developed in around 2011. And then when we're talking about Killsuit, it looks like that was built around 2008 and was operational until the shadow brokers possibly leaked it. In the actual dump, there's a bunch of Python bytecode, but if you decompile the Python bytecode, it's actually super easy to see some of the scripting that they have. This is a custom script. Based on the extension and what it's used for, it seems to me like the naming is Expanding Pulley Script. So it's just for their post-exploitation framework. It's a custom scripting language. This is actually what Expanding Pulley looked like. This was the tool set from 2001. Looks super basic. You have kind of a command prompt with something on the side that tells you what's actually running on the box that you're targeting. In 2005, we see them start writing these Danderspritz scripts, so .dss scripts. And they just added a few more capabilities to the scripting language and just kind of renamed the scripting language. And then actually in 2011, we actually see them start porting a lot of this stuff to Python. So they just kind of gut all that stuff and port it to Python. I assume because it's probably easier to have an operator come in and learn Python or already know Python and build more tooling if necessary, kind of on the fly to adapt to what the operation needs. This is actually what Danderspritz looks like. The default theme is very matrixy. They actually have a bunch of different themes built into it, so I'm glad they spent time on that. And just a few terms that I'll be using during this presentation. Some of it is industry parlance, some of them seems to be specific to this group. The first is target. All that means is an attacked computer, so what I'm actually targeting or what I'm pivoting through in the network. LP stands for listening post, so our parlance would be a CNC server. It's just what it's calling back to. A command, anytime you see a command, it's actually just something running on the target, so it's not something I entered, it's something that I entered and ran on the target. PSP is a personal security product. It's just AV, and they have some really cool capabilities about AV bypasses. The safety handler is what I mentioned that is registered to avoid an operator from doing something really dumb or something built into the framework. So safety handlers are triggered based on how AV is configured and what AV is installed. So if the AV is likely to catch them injecting into the LSOS process, they'll disable that capability and prevent an operator or any other automatic tools from doing that. And finally, the implant's just a backdoor. It's just the actual malicious code that's deployed on the target. Quick overview, like I mentioned, of what exactly it looks like post-exploitation was. It's Fuzzbunch, which is their Metasploit-like framework that was leaked by the shadow brokers. And then you have the exploit. The framework actually has the ability to tell you what exploit it thinks you should use based on what the machine was vulnerable to. So you can just say, hey, use Eternal Blue or Eternal Romance or any of those. And then Double Pulsar is the backdoor, so the actual thing, the ring 0 thing that's responsible for executing shellcode or DLL or whatever you pass it, which is actually your implant. Pedal Cheap, in this case, is the implant. It's what's responsible for executing commands on the box and then calling back to the CNC server that listening post. And when we're talking about Danderspritz as the framework, Danderspritz is actually the listening post. So it is the CNC system that the thing is calling back to, but it's also the software that you're using to communicate with the implant. All right, so what exactly is Killsuit? I have to tease you first and just tell you that based on my research, it looks like, first, Killsuit is not specific to Danderspritz. In a later leak by the shadow brokers, there was a leak of a unmarked United Rake manual, which actually references another sort of lighter weight post-exploitation capability toolkit. And if you read through that toolkit and that manual, they actually mention and call out Killsuit, or Kisu as they call it, as a capability that can be deployed by this toolkit. So it seems like Killsuit is kind of an extremely modular and very easy to configure to use across a wide range of different operations and needs. So, okay, what exactly is Killsuit? Killsuit's actually a super modular persistence framework. It's built to get persistence on the box, to actually deploy something that calls back to you, or deploy recon and data exfil tools. It supports multiple persistent methods. Some of them are really crazy complex. It can actually load different plugins. So a plugin can be either a DLL or a more complex implant that has different capabilities that the equation group needs for this specific operation. And then it actually uses encryption for everything. This is actually why the equation group got its name. Everything that touches this machine is encrypted. Each stage is encrypted separately, making it very difficult for even a well-trained blue team to figure out what the hell is going on. So there's quite a few different terms within Killsuit. Some of them got confusing to me as I went along. The first is this concept of an instance. So an instance is just a different specific instance of Killsuit, which tells you that multiple instances of Killsuit can actually be installed persistently on this machine to launch different implants depending on the needs. Some implants actually have what they call a specific Kisu type. So there's a type registered for Killsuit for a complex implant. The launcher, as they call it, is just a driver that's exploited to get kind of kernel mode code execution if they need that in the implant. And a module is just like a plugin or a thing that's actually running as part of that implant. Some implant have kernel mode capability, user mode capability, and then other types of capabilities that are responsible for silently exfilling data. And then the module store, as they call it, is actually a fully encrypted virtual file system that resides all in the registry. So for persistence, they do need to touch disk, but it all resides encrypted in the registry. There's a lot of cool tooling around interacting with Killsuit within Danderspritz. As you see in this case, I'm actually running a command that's called Kisu survey, and the point of Kisu survey is to tell the operator the type of persistence that's supported by this machine based on what it is. You can see that they have persistence via driver, which is just a driver. So if you're on an operating system like Windows 7 32-bit that doesn't require driver signing by default, you can just persist with a driver. Drop a driver and that's your method, pretty easy. SOTI is a more complex persistence mechanism that I'll cover in just a second, but that stands for solar time. That's what SOTI stands for. It's actually pretty cool how they did this. And then Juvie is just visiting, which I have to say is a fantastic name for a persistence implant, like super cool. And it was actually only supported by XP. I wasn't super thrilled, so I didn't really dig into it, but I encourage some of you to look at what that does. So, all right, what exactly is solar time? So if the equation group's on a machine that requires actual driver signing, the driver has to be signed. One, within the toolkit, they do have the capability, if they have a certificate, to sign the drivers or all the things that they're dropping. But maybe they don't want to blow a certificate that they've somehow retrieved or stolen for this operation. They can actually implant the machine with solar time, which is a super complex volume boot record boot kit. So it's a fully functional boot kit that's responsible for gaining persistence on the machine. It does this by actually modifying the volume boot record, which is right after the master boot record on disk, and then is responsible for kind of hijacking Windows as it works. I'll dig into that in just a bit. And Solar Time actually uses TrueType font files as an encrypted container. So they do drop something on disk that's not in registry. It's a TrueType font file, and that's an encrypted container that actually contains the kernel driver that they're going to load as they're kind of hijacking Windows when it boots. The way it actually works is it'll hijack the BBR, so the volume boot record, and then let Windows proceed booting until it gets to winload.exe, which is the software that's actually responsible from taking the processor from like real mode to what we use today. And winload.exe is patched. They look for the very first driver that has the capabilities that they need and that they know is vulnerable. So they're building a list of all the drivers that are installed on the machine and selecting one randomly that knows it has the capabilities that they need. When this is booting, then they'll actually go ahead and hijack that first kernel driver during boot and start their specific kernel mode. There's a lot of tooling, like I mentioned, that's built into Danderspritz that I encourage you to check out. This is a really sweet Python script that they wrote called check SOTI, so check solar time, which was actually able to just tell me which specific TrueType font file they determined was not being used in the system, and they actually wrote a encrypted container into. So this is where the encrypted kernel mode driver lives. It then starts launching what they call a kernel mode orchestrator. The kernel mode orchestrator is actually responsible for orchestrating any type of access to kernel mode code execution if they need it. So if an implant needs kernel mode code execution, it goes through this kernel mode orchestrator and gets dispatched that way. This, as I mentioned, gives them access to run unsigned kernel mode code and user mode code. It's actually really dope. And then they begin launching implants. Implants can be configured in a myriad of ways. You can say, hey, launch when this service launch, inject into that process's memory, and then start using whatever the implant is. An interesting thing about Solar Time specifically is that Kaspersky actually talked about it in their 2015 report about the equation group. After I had done some digging into how this toolkit worked and what Solar Time was doing specifically, I looked at this report and was really interested to see that they had actually reversed a lot of it. In the report, they called Solar Time plus Killsuit two different frameworks, so a framework and a persistence method, as Grayfish. They thought that Grayfish was kind of the next iteration of their post-exploitation toolkits and implants. That's not the case. It's just a method for persistence. All right, so let's get to the good stuff. How do they actually avoid defenders or blue teams in general? Well, the first mode is, like I mentioned, everything is encrypted with a unique key per target. So they're actually finding like NTFS IDs of specific files that exist that are going to be unique per system and seeding all their crypto with that. So every single target's going to have a unique key. If you have seven systems implanted on your network, they're all not going to be using the same stuff. As I mentioned, they actually encrypt a full virtual file system in registry. And every method or every component of Killsuit's responsible for decrypting the next stage. And a lot of it is process injection for user mode code. If they have to touch disk, remember this is 2013, they actually will drop something and then automatically do time stomping. So if Killsuit or any framework says, hey, I just dropped something on disk, they'll go and automatically match timestamps with an executable that they know was installed around the time Windows was installed. It's all automatic and pretty cool. One of my favorite capabilities that comes with this toolkit is they actually wrote their own custom TCP IP stack to avoid detection on the host. So you're cool, maybe you're a red teamer, you have implants. You're probably not like, I wrote my own TCP IP stack to bypass things type of cool. And if you are, props to you, man. Come talk to me after. So it's entirely done to provide covert non-WinSock API interactions for all of their network tooling and implants. What this means is that you as a defender, like me, I'm a blue team guy, are looking at like Netstat or Wireshark on the machine to see what type of traffic is going through it. You're not gonna see anything. It's all custom written. They have two different versions of this. Fluavenue is an IPv4 driver, so like if you need IPv4, and they're actually super forward looking. I don't know who they were implanting, but they also have an IPv6 capability, so it's pretty interesting. In the Danderspitz framework, there's a lot of tooling to interact with Fluavenue or Dorman Gauze. Here you see me running a command that actually gives me feedback about, okay, is Fluavenue actually properly installed, and which different types of network interfaces does it see available to me for use? With this capability, they did a lot of cool things around using their own custom TCP IP stack. The first is the ability to pivot silently through this node. So they have the capability to do what they call a redirect, which is just kind of put a VPN on this system and pivot through it to reach other systems. If you look at their tooling that is for exploitation, like Fuzzbunch, it's actually capable of using what they call a redirector, which is this, to actually redirect through one system to exploit another, and is all silent. That's pretty cool. And this was a shock to me. They actually can also enable what they call knocking, and the knocking capability is not just like knock a few ports in a sequence. It could be something like this port from this source ephemeral port with these TCP headers, and they can have up to 5 of those options before they actually initiate that knock, which is call back to me or opening a port that's listening on the implant. And then they also have a ton of crazy data gathering capabilities. The first is sort of what you'd expect. They have a bunch of different stealthy keyloggers. There's Strangeland, Yak, and Grok. And all of these are implants that can be installed persistently using a Killsuit type that's called STLA, so Strangeland. And it's all encrypted on the disk when they're actually storing keystrokes. What's actually super cool about this tool is not only does it capture keystrokes and tell you like what LED lights were on the actual keyboard, but when they pull this data back for decryption, they actually have a bunch of translators built into their encryption or decryption tool. So if the operator is targeting an organization that's mainly Arabic speaking or Russian speaking or Chinese speaking, those keystrokes will actually be translated into English and ASCII and whatever they need to make it easier for the operator to understand what's going on. I thought that was pretty sweet. Other capabilities that they have is Dark Skyline. So Dark Skyline is a tool that can be installed persistently, and it's meant to do packet capture. It can actually just do kind of raw socket packet capture as you'd assume from a Wireshark or TCP dump type capability, but it has a built-in Berkeley packet filter. So the operator can choose exactly what traffic they want to save and examine. And this tool can just be installed into an existing Killsuit instance. So if they need persistence for Dark Skyline, they can just say, hey, use this instance that's already stored. And as you would assume, all of this data is encrypted on the disk, again, as a TrueType font file. They really love those for some reason. Some of the cool things that they built into this toolkit is they were being very helpful to their operators, so they built in a bunch of default filters that could be applied to Dark Skyline. So if you're looking for, as an example, Cisco Discovery Protocol traffic, which is responsible for telling different Cisco devices that are on the network who they are and what their capabilities are. Super useful for an attacker that was built in. Conflicker, I thought, was hilarious. If you look at their operational notes from that Swift attack, they run across a lot of Conflicker. They see it all the time, and at times they'll actually uninstall it and clean the machine so they can just leave persistently and not worry about Conflicker. And then they also just capture a lot of MySQL logins and queries. So they're very interested in the type of data that could be stored in a database. In fact, they're so interested in this that Danderspritz and Killsuit as a whole just brings its own drivers for a wide variety of different databases that are available. So if the machine that they're on doesn't have the drivers or kind of the software to talk to the database that they're interested in, they can just bring it in, and it can be installed persistently via Killsuit. They have the ability to just kind of load MS SQL, MySQL, SQLite, or Oracle as the ODBC drivers that they want to use to talk to the database. Another cool thing that was in this leak is they actually have an Oracle authentication bypass that they called Pass Freely. Again, I really love these names, that they can just launch. So if you're using Pass Freely, it'll just be like, cool, here's your auth, go ahead and pull all the stuff you want from this Oracle database. And then more tooling that they built is all about canned query plans. So if you're touching a thing like Kaspersky or SolarWinds or something like WSUS Server or SharePoint, they were very interested in that. A lot of their tooling around MySQL was also data exfil and also changing configurations of servers like WSUS or Kaspersky or McAfee were the capabilities. Another really cool tool is called Magic Bean. And Magic Bean's actually responsible for man-in-the-middle, like Wi-Fi man-in-the-middle capabilities. So if they're in a position where they actually want to grab like Wi-Fi credentials out of the air, they can install this type using Killsuit, and the type name is MABE, so Magic Bean. And it just installs a packet, like if they need it, they can install a packet driver with packet injection capabilities. So if they need to inject packets to do like deauth or other stuff, they can just kind of install that driver on the fly. And you can actually see me here just running a command that tells Killsuit to install Magic Bean. The capabilities are pretty cool. If you look at some of the exploits or issues that came out with Wi-Fi protected access and like all that stuff recently in 2017, some of those capabilities actually exist in Magic Bean. So they were way ahead of their time from a Wi-Fi exploitation perspective. And of course, as the Equation Group, a lot of their time is spent trying to figure out how to do super stealthy data exfiltration. So a lot of that comes to, once again, designing a fully custom network protocol. So if they're in a situation where they know that the defenders have good network visibility, they've designed their own custom network protocol. There's two components to this. There's an implant called Straight Bazaar, which is responsible for actually doing stealthy data exfil. So this is the implant that actually uses the custom network protocol. The custom network protocol is super cool. It's called FreezeRAMP, and it's very IPsec-like. So if you've looked at IPsec, like VPN tunnels, this is very similar, and some of the terminology is very reminiscent of that. FreezeRAMP actually also has a bunch of what they call adapters that allows them to kind of inject traffic into different layer 2 or like transport layer solutions. So like if they need TCP or UDP or ICMP, whatever it is, they have an adapter that can kind of translate this traffic to how they want to exfil from it. If you're looking at FreezeRAMP within Danderspritz, there's a lot of tooling that lets you see the types of links that are established between the listening post and the actual FreezeRAMP using implant. You can actually see here that there's a bunch of security associations. So once again, if you're familiar with a VPN or IPsec capability, security associations is exactly what they use. Here what you see is that my machine, which is running Danderspritz, is called an address of Z001. And then all the targets kind of just go up from that sequentially. So the first target I connect to will be Z002 and so on. and they'll actually establish bidirectional security associations to send encrypted traffic back and forth. If you're interested in what this traffic looks like on the wire, the team at Forcepoint did a really fantastic write-up of how they reverse engineered this traffic. I don't know if they found freeze ramp because they don't mention this in their paper, but they just kind of looked at the encrypted network traffic and broke down how it works. So if you're interested in understanding a bit more of that, I recommend that Forcepoint white paper. All right, cool. So what other tools or things do they have from a persistent data exfil capability? There's Somber Knave, and Somber Knave is used to hijack disabled Wi-Fi cards. So if they're in a secure facility where potentially the Ethernet network, the wired network, is air-gapped, they can actually re-enable a previously disabled Wi-Fi card and then use that to kind of exfil all their data across it. And you can actually use the credentials that you stole using Magic Bean to auth to Wi-Fi networks and exfil data that way, or you can use just an open Wi-Fi network nearby. And just like with all these other systems that I mentioned, it has its own separate kill suit instance, and this is SOKN. Boy, let me tell you, was it fun finding out what these things stood for. All right, so here you can actually see me installing this Somber Knave tool. And before we keep talking about these capabilities, I want to loop back to one of the implants that I talked about, which was Straight Bazaar. So Straight Bazaar is responsible for, again, doing stealthy network exfil. But they also have the capability to turn it into what they call a Straight Bazaar shooter. And a Straight Bazaar shooter is actually a super cool capability that they use when they need to target hard-to-reach targets. So let's say you're the Equation Group, and you happen to have the ability to monitor 80 to 90% of global network traffic kind of at scale, and you're trying to target a hard-to-reach organization. You can actually put what they call a task on a specific listener, which, again, is a global network of listeners, to say, okay, I know that this network administrator at company X or organization Y has this Yahoo account, or is logged into Facebook with this session ID, or all sorts of other different tasks. And what their network of sensors will do is identify that and say, oh, hey, that guy you asked me to watch for, I actually just saw him log into a server. It'll send a tip-off to a tasking engine, which is then responsible for telling the Straight Bazaar shooter to do man-on-the-side at-scale packet injection and beat the actual response packet from the server back to the target and redirect them to something malicious. I just want to stop for a second to tell you that. Like, if they were trying to hack into a hard-to-reach network, they did at-scale man-on-the-side. They literally found the geographically closest quantum shooter to the target and did passive man-on-the-side injection. This requires them to be able to kind of calculate the TCP sequence number that will be at play by the time this quantum shooter is actually firing its man-on-the-side traffic, and that's super cool. And what actually happened was the quantum shooter was responsible for injecting some JavaScript that redirects the target to an exploit server. So if you've seen an exploit kit like Black Hole or Fiesta, all these different exploit kits, this server is sort of the same but full of O-Day. So from what we could see, they had 0 days for Safari on iPhone and Mac and Internet Explorer that they could drop on the target depending on what they had. And the way this tooling worked is, as I mentioned, the Straight Bazaar shooter is responsible for redirecting to the Fox Acid exploit server. So that's the exploit server that's responsible for deploying some sort of code to the target. The exploit server deploys a tool that they call a validator. And the validator, as you would assume, is responsible for confirming that they actually implanted the right target. So not only are they tasking based on session IDs or Yahoo email that you're logging into, but they also deploy a validator that's responsible for confirming that they actually did implant the right target. If they didn't implant the right target, they just kind of silently uninstall that and back away. If they did implant the correct target, they deploy that United Rake framework that we mentioned earlier. So United Rake is just a lightweight version of a post-exploitation kit. It'll just call back to a CNC server, a listening post, and just tell the operators, hey, I'm here, what do you want me to do? And from there, they can go ahead and upgrade it to a session of Danderspritz or other tooling if they need it. So quick story time around how I found this and how I want to encourage you to look at this. So last year I mentioned I did this Danderspritz talk, and my buddy Casey Smith, SubT on Twitter, really recommend you follow that dude, super bright, and another friend, we're all hanging out at Casey's house, and none of us are like boot record people, you know, we're like buying a bunch of forensics and like file system forensics books to figure out how Solar Time is working. And what that meant is that we were just like persistently installing a bunch of tools consistently using Killsuit. So we're like, okay, let's just keep installing these things. And eventually, we ran across the fact that whenever we deployed a implant persistently with Killsuit, like pedal cheap, we saw it run a command that was like Kisu install type whatever. And we started digging into, well, what does that mean? Like, what's a Kisu install? We're kind of feeling dumb. We can't figure out how this bootkit works. Let's just look at something else. So we run another command that says, hey, show me all the Killsuit installations on this box. What we end up seeing is that they have this thing that they call a Kisu ID, so a Killsuit ID, and they have a little like PC next to it. PC stood for pedal cheap. So we start thinking, I wonder why they have IDs on these things, and what else could I install with Killsuit that would be interesting to me? And what I remembered is, once again, they had a bunch of Python that I could read without having to reverse a bunch of things. And in a Killsuit folder that we were looking at, there was this ids.py file. And I was like, that's probably useful and related. And what we saw was that that PC thing is actually listed in there. And when we looked, that was what it was in hex. So we're like, okay, what if we do like Kisu install all of these things? So that's what we did. We just like started installing stuff. We're like, no idea what this does, but cool, I'm just gonna install all of it. So we end up with this box that's got like, I kid you not, like 13 different implants. We have no idea what they do yet, but we're like, cool, these are all installed. That's super sweet. Let's start figuring out what they do. So what we actually end up doing is looking at that check SOTI script. So that script that I mentioned that looks for a Solar Time container and how it's configured, it had this super helpful piece of code that was like, hey, I don't know what version this is, but if you run double feature, it will tell you. So we're like, double feature? Yeah, that sounds like something I want to look at. So we just kind of ran a double feature report. And let me tell you, was that useful as hell. So double feature is actually responsible for figuring out all the things that are implanted by Killsuit and Danderspritz. It actually spits out what is installed and the full name of the implant. So that was pretty cool. And then also tells you a bunch of other information, like where in the registry they installed all of their persistent stuff for that virtual file system. They'll tell you, hey, this is the launcher driver that we're going to exploit to actually get persistence on this machine and run kernel mode code, and a bunch of other cool stuff. So we end up just running a bunch of double feature reports. Something interesting about double feature, which if you're investigating Danderspritz and Killsuit, I really recommend you run, is one, you can just run a standard double feature query, which is what we did. We just queried everything. But it also has features built in to enable debug logging on United Rake. So super helpful that they built a tool that enabled logging on all of their persistence toolkits and post-exploitation frameworks. So double feature is a super useful system that I recommend you look at if you're going to be digging into this. So let's talk about just a few of the implants that are supported by Killsuit. And if you look here in this slide, the ones that I've highlighted are the ones that I mentioned in this talk or that I know what they do. So as you see this, please consider helping me reverse this. We have Morbid Angel, we have Savage Angel, we have Straight Bizarre, we have Magic Bean, we have Chin Music, super cool. Dementia Wheel, that one's fun. We have Tilt Tsunami, I really like that one, and Wraithwatch. Funny thing about Wraithwatch, I really recommend you go onto LinkedIn and just like search Wraithwatch. You'll find a bunch of interesting people who have had Wraithwatch training. That is terrible OPSEC. Other things, we have Double Dare, we have Magic Grain, Magic Monkey, Sleepy Sheriff, we have Snuffle Unicorn. I really want to know what that one does. Woozy Ramble, Somber Knave, and then Strangeland. So again, let's fill in a few more of these. Let's figure out what they do. All right, so as I mentioned at the beginning of this talk, my entire goal with this was to enable research and enable other people to look at Danderspritz and understand the capabilities. There's been at least 13 years of work into this tooling, this tradecraft, and these capabilities, and now it's out in the open. We need to look at what they're doing and what other organizations or criminal groups are going to start using against us as the blue team in the future. So in order to enable research, I actually built a fully functional Danderspritz lab that you can bring up in 2 commands. You just have to run Packer to build the lab, and then Vagrant up. And then you'll have a fully functional Danderspritz lab with Danderspritz as the exploitation system. It includes Fuzzbunch. You'll have the target that you should hopefully be able to implant and play against, as well as a domain controller and a bunch of tooling around doing forensics and discovery on that machine. The domain controller includes things like event log forwarding and other things that were super helpful to me when I was trying to understand how this toolkit worked. So, quick review of what we talked about today. So we talked about Danderspritz as a super cool framework, and we talked about their post-exploitation capabilities, not just using Fuzzbunch, but doing at-scale man on the side, which is still mind-blowing to me. And I told you about Danderspritz Lab. So I actually own Danderspritz.com, by the way, so if you guys want to look at that, I've been putting a lot of stuff on there. And please take a look at Danderspritz Lab, Danderspritz Docs, and let me know if you have any questions. Just a heads up, we have a few Randori shirts, so if you're interested, not that many, but we have a few, please come up to me and let me know. Thanks.